Yeah, in the last slide I have shown you symmetry property with respect to plane of symmetry. Now I am showing symmetry with respect to C2 symmetry, right? Here again I have taken psi1 and psi2 or bimolecular orbitals. Now psi1 already calculated, 0 nodes, psi2 already calculated, and number of nodes is equal to 1. Here number of nodes is equal to 0, right? So drawing the bimolecular orbitals in such a way that they are 0 nodes. Now C2 is nothing but rotational axis of symmetry, right girls? So you just try to rotate it by 180 degrees. Now once you rotate it by 180 degrees, the unshaded lobes, right, they go on top and the shaded lobes go on bottom. That means you will not result in an equivalent configuration. So once you do not get an equivalent configuration, then C2 is absent in this psi1 bimolecular orbitals. Then it is said to be anti-symmetric with respect to C2 axis of symmetry. Now you look for the psi2 bimolecular orbitals, right? This arrangement is in such a way that it has one node. So once you have shaded lobes on opposite side, right, then it is one node is present here. Now just try to rotate the plane, try to rotate the rotational, put the rotational axis here and rotate it by 180 degrees. So once you rotate it by 180 degrees, again the shaded will get exchanged. This will go this side and this will go this side, right? Likewise unshaded also exchanges. Then you will result in an equivalent configuration. That means C2 is present in psi2 molecular orbital. So it is said to be symmetric with respect to C2, right? Now we will discuss the molecular orbital of ethylene, right? Ethylene, it has got, what is the structure of ethylene? CH2 double bond CH2. That means how many pi electrons are there? 2 pi electrons are there. One double bond, 2 pi electrons. Now 2 atomic orbitals, linear combination of atomic orbitals will result in 2 molecular orbital. Now the distribution of bonding and anti-bonding we already know, right? N by 2. So you will have N by 2 of bonding molecular orbitals and N by 2 of anti-bonding molecular orbitals. Pi, pi star, they are also designated as psi1 and psi2. Now for drawing this pi molecular orbitals, you have to look for the number of nodes. Now this is, I have shown you psi1. Psi1, that means by applying the formula for calculating the number of nodes, n minus 1 is equal to, right, that will give you number of nodes. So n is here 1. So 1 minus 1 is equal to 0. 0 nodes means both the shaded lobes of the pi molecular orbitals on top and unshaded on bottom. So here in this type of arrangement you have no nodes, right? Likewise this is, right, psi2. Psi2, 2 minus 1 is equal to 1. So you have to draw the pi molecular orbital in such a way that one node is present. Here one node is present, right? Opposite arrangement, one node will be present here. Now just look, orbitals I have given, this is pi and pi star orbital. Now symmetry properties also we have to list out, right? So if you look for the sigma plane of symmetry, right, whether it is symmetric or anti-symmetric or asymmetric, right, then you just observe, if you put a plane here, right, this half is reflected here, yes, this half is reflected here, so sigma is present. So once sigma is present in psi1, then it is said to be symmetric with respect to sigma, right? Now look for psi1. Psi1, it has got one node. So if you try to put a plane, right, in between these two pi molecular orbitals, is this part reflected here? No, it is not reflected. It is not a mirror image reflection. So once it is not there, then sigma is absent. Sigma is absent means what you will write? You will write it is antisymmetric with respect to sigma. Now go for C2 axis of symmetry. Now if you put a rotational axis in between these two pi molecular orbitals and try to rotate it by 180 degrees. Once you rotate it by 180 degrees, what happens? I already told you, the shaded will go bottom, the unshaded will go to the top. So you will not result in an equivalent configuration. So once you are not resulting in an equivalent configuration, then in this C2 is absent. C2 is absent means what you will write? Antisymmetric with respect to C2, right? Now look for this arrangement, right? Here also the rotational axis is passing in between these two, and if you try to rotate it by 180 degrees, right? Once you try to rotate it by 180 degrees, this will get upon rotation this place, this unshaded will go to this place. That means you will result in an equivalent configuration. So once you are resulting in an equivalent configuration, you will write it as symmetric with respect to C2 axis, right? Now the electronic configurations of both Psi1 and Psi2. Look here girls, in ethylene molecule how many pi electrons are available? I said 2 pi electrons are available, right? Yeah, so this is the ground state electronic configuration of ethylene molecule, right? Pi and pi star, 2 molecular orbitals, right? Yeah, so this is one Psi1 and this is Psi2, right? Psi1 may you have 2 electrons because it has got only 2 electrons according to Obverse principle and all, right? The electrons will occupy lowest energy. So pi is lowest energy when compared to pi star molecular orbital. So both the electrons are accommodated here and 0 electrons are here. So by looking the same thing, right? Here this is pi and this is pi star molecular orbitals. Both the electrons are occupying here. Here 0 number of electrons. This is energy axis, y axis if you take. This is said to be HOMO, highest occupied molecular orbital, and this Psi2, it is called as LUMO, lowest unoccupied molecular orbital. It is unoccupied, no, there are no electrons, that is why it is called as LUMO. This has got occupied electrons, that is why it is called as highest occupied molecular orbital, right? So this is the ground state electronic configuration of ethylene, right? Now go for the excited state configuration of ethylene, right? Already I have shown you the ground state electronic configuration of energy axis, right? Yeah, this is pi molecular orbital and this is pi star molecular orbital. Both the electrons are here and this is not there. So this is HOMO and this is LUMO, right? Once you supply an energy that is in the form of electromagnetic radiation, right, the electrons, it absorbs energy and gets excited to high energy orbitals, pi molecular orbitals, right? So this, how you write the excited state? Yeah, so one electron is here, another electron is getting excited to Psi2 orbital, Psi2 molecular orbital, right? Yeah, so you have Psi1 and this is Psi2. This is pi and this is pi star. Now one orbital is there means this is one electron is there in this orbital means this is HOMO, right? Is any LUMO is present? Yeah, you have only 2 pi molecular orbitals. There is no LUMO because both the only 2 molecular orbitals are present and both are occupied by 1 electron. There is no unoccupied molecular orbital. So in this case LUMO is absent. LUMO is absent. That is what I have written here. Excited state configuration of ethylene. Yeah, pi is having 1 electron and pi star molecular orbital is having 1 electron. This is Psi1 molecular orbital and this is Psi2 molecular orbital, right? Psi1, Psi2, right? Yeah, so this is having 1 electron, this is having another electron. There is no LUMO present here. So got the clarity about HOMO and LUMO? Yeah, you have to see first how many pi molecular orbitals are present here in ethylene molecule. 2 pi molecular orbitals are present, right? And 2 pi molecular orbitals, the occupied molecular electron occupied molecular orbital is called as HOMO. And you have to see girls here, both pi molecular orbitals are having electrons, but this is considered as HOMO, this is not considered as HOMO. That means the highest energetic molecular orbital with electron is called as HOMO. Okay, got the clarity? Out of these 2 molecular orbitals, which is more energetic or high energetic? This is high energetic, and the electron with this high energetic molecular orbital is called as HOMO. So LUMO is absent in this case, right? Now next discussion is molecular orbitals of 1,3-butadiene, right? Yeah, molecular orbitals of 1,3-butadiene. This is the system, right? 1,3-butadiene, first carbon, second carbon, third carbon, fourth carbon. Yeah, you have 4 carbons, 2 double bonds. First carbon you have a double bond and third carbon you have, how many pi electrons are there girls? 4 pi electrons, 1 pi bond and another double bond. So you have 4 pi electrons, right? Yeah, just pi molecular orbitals of 1,3 butadiene. It is a 4 pi electron system. Now I have given a clear I have gone it in the form of a tabular column. You have your wave functions, that is nothing but abbreviations of the molecular orbitals, waves, molecular orbitals, number of nodes that are present, and then whether it is symmetric with respect to sigma or not, whether it is symmetric with respect to C2, ground state electronic configuration, and its excited state electronic configuration. The same points what we have discussed for ethylene, we will discuss it for 1,3 butadiene system, right? How many pi molecular orbitals will be there, girls? Here 4 atomic orbitals are there. So linear combination of atomic orbitals will result in an equivalent molecular orbitals. So 4 will combine to give 4 pi molecular orbitals, right? So the lowest will be assigned or abbreviated as psi1, next is psi2, next is psi3, psi4. So these are the 4 pi molecular orbitals that are resulting. Now depending upon the number of nodes, you have to draw the pi molecular orbitals, right? Here psi1, that means 1 minus 1 is equal to 0. So 0 nodes. That means on top all the shaded and on bottom lobes will be unshaded, right? That means you have 0 nodes. This arrangement will give you 0 nodes. So you have to draw it in this way. Now number of nodes is 0. Now whether with respect to sigma it is symmetric or not means I have written symmetric. How it is symmetric? If you put a plane here, right, this half is equal to this half. That means it is symmetric with respect to sigma. Now if you just try to pass a rotational axis from here center and rotate it by 180 degrees, right, the unshaded bottom lobes will go on top and the shaded bottom shaded lobes upper lobes will be going this side, bottom side. So that means C2 is absent here. Once C2 is absent, then it is antisymmetric with respect to C2. Now electronic configurations I'll tell later on. We will go for psi2 configuration. Psi2 pi molecular orbitals. Psi2 pi molecular orbitals, again 4 lobes we have to draw, 4 pi molecular orbitals we have to draw. Now how many nodes should be there? 2 minus 1 is equal to 1, right? 2 minus 1 is equal to 1. So you have to incorporate one node, right? So I have incorporated one node here. The left pi molecular orbitals, left 2 pi molecular orbitals, the shaded lobes I have kept it on top and the unshaded on bottom, and the right hand side both the molecular orbitals top lobes, right, they are unshaded. This was by mistake. Both are unshaded and bottom both are shaded pi molecular orbitals. Now this here I have because here the opposite arrangement is there, you'll have one node here. Here no node is there, here no node is there, right? One node is present in between these 2 pi molecular orbitals, right? Number of nodes is equal to 1. Now sigma, if you try to put a plane and then see this half is equivalent to this half, no, it is not reflected equal, right? It cannot be reflected because here the shaded lobe is not exchanged with unshaded. It cannot be exchanged with unshaded. Here if it is shaded, then here also you should have shaded for C2 for sigma to be present, but here it is not so. So it is antisymmetric with respect to sigma. So once you try to look for C2, yes, C2 180 degrees rotation here. If you try to rotate, right, if you try to pass the rotational axis from this center by 180 degrees, this will get exchanged with this and this will get exchanged. So you'll get an equivalent configuration. So it is symmetric with respect to C2. Now go for psi3 pi molecular orbitals, right? Girls, here also I have given this wave equations. One node means the node is passing here. Here psi3, 3 minus 1 is equal to 2 nodes here, right? You have to draw the pi molecular orbitals in such a way that you should result in 2 nodes. So this is the best arrangement for that. Girls, always for writing the pi molecular orbitals, remember that on the extreme left hand side you fix this configuration. On top you take shaded and on bottom you put unshaded. Now remaining pi molecular orbitals arrangement should be depending on the number of nodes. If you want 2 nodes, then immediately one node you can put here by taking the unshaded on top and shaded on the bottom, right? Likewise same if you take, and here if you reverse it, then you get 2 nodes. Can you see here? This is opposite here, this is same, so there is no node here in between these 2 pi molecular orbitals. But then if you look here, again one node is there, right? So you have 2 nodes. That's what I have written here, 2 nodes, right? If you put a plane here, right, is it equivalent, right? This half is equal to this half. it can be it is reflected in the mirror like this. So it is symmetric with respect to sigma. Likewise with C2 it is antisymmetric, because once it is symmetric with sigma, then obviously it will be antisymmetric with the C2, because if you try to rotate it like this, passing the rotational axis here by 180 degrees, right, this bottom shaded will go exchange with top here, so it will not result in equivalent configuration, so it is antisymmetric. Now go for psi4 molecular orbital, right? Psi4 molecular orbital, right? Yeah, 4 minus 1 is equal to 3 nodes, 1 2 3, right? So you draw the molecular orbitals in such a way that you get 3 nodes, right? Yeah, first I said extreme left hand side fixed molecular pi molecular orbital shaded on top and shaded on bottom. Next, because 4 molecular orbitals are there and you require 3 nodes, so obviously all should be opposite, right? That is how I have drawn this opposite to this, and then this is opposite to this, right? So 3 nodes are there, yeah, opposite configuration, here also opposite, here also opposite, so you have 3 nodes here. So number of nodes is equal to 3. Now if you try to put a plane here, is this reflecting here? No, it is not getting reflected. This is also not reflected, so it is sigma is absent, so it is antisymmetric with respect to sigma. Likewise if you go for C2, yeah, if you rotate it here, if your rotational axis pass from this center and try to rotate it by 180 degrees, this will go for exchange, this will go for exchange here, this will get exchange here, this will get exchange here, so it is perfectly symmetric with respect to C2, so it is symmetric. Now go for the ground state as well as excited state electronic configuration. How many electrons in this? 4 electrons. I said, and according to Abbo's principle, right, the 2 electrons first will occupy the lowest psi1, this is psi2, this is psi3, and this is psi4 molecular orbitals, right? So since 4 are there, 2 will occupy psi1, 2 will occupy psi2, right? Psi3 and psi4 are 0 0, right? Yeah, now what is HOMO in this case, girls? HOMO means occupied molecular orbital, and that too highest energetic occupied molecular orbital. Out of these two, which is more energetic? This is more energetic, so this will form the HOMO. And what is this? Lowest unoccupied molecular orbital. That means the pi molecular orbital which is unoccupied and which is having less. For example, if you consider these two, this is unoccupied, so this becomes LUMO, and this is nothing. Yeah. So if you have to write the electronic configuration, ground state electronic configuration, then you write it as psi1 to psi2 to psi3 0 and psi4 0. Good. This is how. And what is, if they ask you a question which is HOMO and LUMO from this, means this becomes your HOMO and this becomes your LUMO. Psi3 0 is the LUMO, psi2 2 is the HOMO. Now excited state configuration, you know, once you irradiate it with electromagnetic radiation, one electron from psi2 will get excited or promoted to psi3. So that is what I have written here. Now look for this, yeah, which is HOMO and which is LUMO. Out of this three orbitals, right, psi1, psi2 and psi3, right, 3 orbitals are occupied with electrons. Now which is highest occupied molecular orbital? Obviously this psi3 becomes HOMO. Now psi4 automatically will become LUMO, unoccupied molecular orbital, right, lowest unoccupied molecular. So if you have to write the excited state electronic configuration, then you write as psi1 2, good, psi2 1, psi3 1 and psi4 0, and then psi3 is the HOMO and psi4 is the LUMO. Okay, fine girls, thank you.